Fauna Robotics unveiled a new robotic platform called Sprout that's designed to move out of the lab and into the real world and hopefully help shape the future of robotics. Rivr is innovating using quadruped bots for doorstep delivery, and eFlesh has developed a way to build highly customizable, low-cost magnetic tactile sensors that you can build with just a hobbyist 3D printer and off-the-shelf magnets. All that and more in today's chat. I have Scott Walter, Gustav Anderson, and Mehrdad Faramani with me today. Scott is a mechanical and aerospace engineer and two-time founder of robotics companies. Gustav is a hand surgeon and an associate professor of anatomy in northern Sweden. Mehrdad, also based in Sweden, he's been designing humanoids and other service robots for over a decade. He's also been advising startups and investors on the robot product roadmap. So, welcome, Paper. Welcome, Scissors. Welcome, Spark. Good to have you back.
Well, rock, for those who don't get it, rock, paper, scissors, spark.
Got an even bigger pair of scissors today.
Yeah, so we've got a lot to talk about today, but I think we should begin first with this cute little bot, the Sprout. Does it get cuter than that? So this is from Fauna Robotics. This robotic platform is, according to them, that one that is designed to move out of the lab into the real world, closer to the people who will shape what robots become next. So is this the Unitree of America?
Absolutely. Yes. And one of the first things I saw when I looked at it is that it reminded me a little bit of the Boston Dynamics new Atlas, right? The ankle and everything. And you know what's kind of ironic is that one of their customers is actually Boston Dynamics.
Oh, okay.
I'm just a little bit upset that they only had a hinge this way for his eyebrows. I kind of prefer it to go this way when it's turning upon us and the destroy setting kicks in.
So you see they have only 1 degree of freedom there at the ankle. So you notice how they're lacking a roll there. So they intentionally remove that degree of freedom. So it's only a 5 DOF leg because, again, they're making the compromises on how do you come up with one that has a minimum number of degrees of freedom. And I think it's an okay choice to be able to do that. But, normally you would want to have that. So when you're walking on a flat surface like that, it's okay. But if you were to spread the legs too much, then suddenly the feet are no longer going to be parallel to the ground. But what's interesting is they took a degree of freedom there, but then they added a bunch of degrees of freedom we didn't exist, like eyebrows. And so, but it's there for the expression.
Yeah.
Customize it with stickers if you want.
But that's one thing actually I wanted to say, regarding, is it the Unitree of US? What I think is that it's being designed very specific for very specific application. It's one of those robots that when you look at it, it's like the affordance part, right? You kind of can assume what the application is, which is probably inside homes with children and so on. So we know obviously most of their customers early on would be research centers and other robotic companies, but maybe their intention was to just build it specifically for children, which I think they kind of nailed it, right? Design.
Absolutely. So it's dual purpose. Research labs are wanting something else that they can use other than Unitree, and it's opened up like that. So it's going to have that. Plus, it's going to go into home, which means it's not just research labs. We're talking hobbyists now. It's like within the range of that people will put around and figure out how you can do the home application. So it's lighter than Unitree. I think it's at 30 kilograms. It's a little bit lighter, so it's the same as the 1X. It looks very soft. They intentionally made the height, at a specific height, limited the degrees of freedom where you needed. So I think it's might be just a 1 DOF hand. And even then, I'm not sure if they have full degrees of freedom in the wrist. So it might be a 6 DOF arm plus the additional DOF for the hand to be able to grab. So they made. I think they did a very good job of going through the checklist of what degrees of freedom do we really, really need, and if we had to take them out, because this is the first question I always ask all these robot designers. If you had to add one, what would it be? If you had to take one away, which would it be? And they've taken my exercise very seriously there and gone through to go ahead and do that and decide what is necessary and what's not to make it very soft. And I think the thing that surprised everyone is that they kind of came out of nowhere they're out of New York
Yeah.
City. They're not out of the Bay Area. It's like, they're the East Coast now. And New York is shocking everyone right now with how much they are playing in this space.
I know.
Yeah,
Remember the Kyber Labs guys we spoke to.
Yes. I mean, everyone thought that the East Coast center was going to be Boston, and Boston's actually losing its shine a little bit. A lot of companies are kind of moving out of there and either going to the Bay Area. So they still have a little bit there, but New York is doing something about really attracting a lot of talent there. A lot of the startups are happening, and their mindset's a little bit different than San Francisco. San Francisco is more like their heads in the clouds. They're way up there, really looking ahead. New York is more grounded in a way. They're like, let's make these things practical and useful right out of the box. Let's not, promise something that's going to be great 10 years from now, but let's really come up with something that you can start building on top of. And I like that dynamic. I like the fact that we get this East Coast, West Coast rivalry going on. And I hope it stays that way. I don't want San Francisco to become New York, and I don't want New York to become San Francisco. I want them to keep doing what they're doing.
Yeah.
I think a good twin to this product could be Cartwheel Robotics, right? I think Scott, you know Scott Lawally from Reno, and it was exactly kind of the same configuration, the same application even, and it seems like, but they also started almost at the same time, and it seems like they are winning the game, this Fauna guys, over Cartwheel Robotics. But let's see.
Yes. They get out there really quickly, and you notice that their waste is not exotic. It's basically the same FAR kind of waste as you see in a unit tree. So they just decided probably to simplify the actuator count, so it looks like the knee and the ankle are the same, kind of like what Atlas did. Like they got it down to 2, but in doing that, they just had to decide we're not going to put the ankle roll in there. We don't think it's all that important. It's just going to complicate everything. So that's how you reduce the cost and complexity and maybe make it a little bit safer. I mean, look at that. You can just pick it up like that very easily.
Yeah, so easy. I have 2 questions, right? First, are there any advantages or disadvantages of this particular form factor? Because it's like a midget. I don't know if it's politically correct to use the word anymore, but it's a lot smaller. Let's say it's pretty much a child's height. How does scaling form and functionality when compared to a bot like that is more adult human size, like a Unitary and others? Does it play any
But even the Unitary is about this size as well. And especially the R1 is even smaller than the G1. So they've come a little bit down to bring the cost down. And there's the scaling laws of mass go as basically your length cubed. So
say that again.
This is cubed. So think about it. If you take a look at a sphere, and if you double the radius of the sphere, the volume of the sphere is now 8 times. Right. It goes as a cube law. And so the same thing with humanoids, that if you decide to double the height, the mass is almost going to go up 8 times as a result. I mean, it's not exactly like a sphere, but it's kind of along that. And the biggest danger, the biggest safety hazard of all the bots is not how tall they are or anything else. It's all about mass. You've got to reduce the mass. And without coming up with some like super exotic materials and everything else, as you start to get up to normal human height, it becomes just way massive. And so if you want to make them safe, you really have to be in that little over a meter kind of height. But from the standpoint of a researcher, you can still do a lot with something at that height. You can't reach up in the cabinets or other things, but you could still do quite a lot. And again, I'm thinking like the hobbyists. I'm thinking of high schools that are going to be like, say, let's start training policies for these. All these robot clubs that you have in the high schools. This is perfect. This is absolutely perfect. And this is what we want to do. We want to train the next generation of roboticists to understand how all this stuff works. But you need hardware to be able to do it. Now, I can remember when my brother was in high school back in the late 60s. He took a class in programming, and they didn't even have a computer to use. I mean, literally, they wrote things down in graph paper. They learned the syntax, stuff like that. And they had to run these programs in their head to kind of figure out what was going on and understand it, because they didn't have access to computers. So think about how silly that was to learn programming without even having a computer to run on. How can you learn to program robots if you don't even have a robot to use? Now, suddenly they're available.
I can answer your question. Oh, sorry, Gustav, do you want to?
No, just thinking, were they like taking the the role that K-Scale expected to have, this California startup in the garage that kind of went away, sadly.
Yes.
Guessing they have a similar.
K-scale, the scale was too big.
Yeah.
They were more like very open source, right? They were focusing on being open source, but I don't know how much these guys are all. Okay, I can answer your question, Roy, then maybe in another way, because it was a very good question. So if you make a scale of on one side we have utilitarian robots. The robots can do utility, proper tasks, and the other side of the spectrum we have entertainment robots. Then, in my opinion, this goes a lot to the entertainment side, and you're not really focusing on so much utility. I'm not even sure if it can like grab stuff properly or something like that, which is not the point, right? And then if you have another spectrum, maybe perpendicular to this, and that be open source versus a finished product or something. I still think this product is less open source than Unit 3, but probably later experts should correct me here. But also less open source than K-Scale maybe regarding what it has. So it has a very sweet spot where it's standing, which is more like an entertainment robot that does not have to be utilitarian, therefore does not have to be a human form factor, like an adult form factor. And this is very good enough as it is, and it's standing in a part of the market that was not so much filled so far, I would say. The other thing I can add is that we can maybe get into it later, but price-wise, I don't know how it could compete with Unit 3.
I don't think we've got any idea of the price, do we, Scott?
I didn't see anything, so I'm not sure about it.
Okay. So the other question I had
was there anything in there? I mean, we can always ask chat.
I just saw a few posts on X, something around 50K, but
that would be kind of high compared to what you get for Unit 3. Yes.
Okay. So the other question I have is, if you look at the motion and the degrees of freedom, right, which we talk about so often here, is it enough to be anything more than a hobbyist's platform to learn and experiment with robotics? Or do you need more degrees of freedom? Do you need more sophistication in the mechanics of it in order to do advanced development of robotics?
I'm thinking mostly like how much can it lift? I mean, the grippers are good for a lot of pick and place, but will it be able to kind of grab anything of any weight bigger than a cup of water? Maybe not, but it's. I mean, that's for me, it's an important factor in how useful is it. You could, as you say, do a lot of research with this kind of bot in the different environments and whatever, but will it be able to pick up a sheet of metal and move it across the room? And I don't think so. Hopefully it can pick up the toys and the clothing, but more than that.
I think we have something to go by, because in their article, this is what they say. They say, grounding us in the physical world through tangible, meaningful interaction, robots can be present in a way software alone cannot. People need to be around people, and so do robots. The economics point in the same direction. Over 80% of today's workforce is in services, not manufacturing. Labor shortages in healthcare, education, elder care are already here and getting worse. The need for robots in human space is urgent. And first time the technology is within reach. That's why build Sprout. But it's interesting. They call it the real promise of robotics is helping people where they actually lead their lives, homes, schools, offices, and all the spaces in between. And they say C3PO, Rosie Jensen, Wally, these are all helpers, sidekicks, and companions. So I think we're getting a sense of what they have in mind. That it's kind of initially targeting a different sector. Different profile, maybe not hardcore robotics labs and startups. Or am I getting it wrong?
I think you're very precise here. So we had a few robots similar to this before, right? So Cartwheel Robotics Yogi. Then we had Andromeda from this Australian company. I forgot the name. And the colorful one, which was for elderly houses and had a few degrees of freedom. And then we had the small versions of Booster Robotics, Unit 3, and then the small version of Engine AI. So they were Chinese ones, Engine AI, Booster Robotics, and Unitree are not really trying to optimize it for a certain application. They are very obviously saying it's general purpose, but a small form factor. But this robot and the equivalent Western versions are trying to say this is a small robot for this certain application, which kind of makes a lot of sense. Now, when I heard, elderly cares, maybe kindergartens, education, all those areas. But one thing Scott probably remembers, for me, these robots are all goes into the category of Null from Aldebaran's. You know that robot, right? And that robot was how many years ago? Like 12, 13 years ago. And it had a big impact. It was like every robotics lab I was going to, they had one of those. But at some point, they stopped buying it. And it was a pretty sophisticated product, right? But this one is still bigger than that, actually. That was like 60 centimeter. This is like 1-ish meter. But I don't know how they want to pull off the business model, because that was SoftBank, Aldebaran's, right? And then they still couldn't make financial sense out of it. But let's see how these guys can do it.
Yeah, and of course the update is that 13 years ago you didn't have a lot of the edge compute and everything else that people could use for research. So it may have some value. So I believe it's in a sweet spot, and I'm sure this is not their last product. The idea is that they've got a roadmap that you would build on top of this, and that what you probably learned from that you would be able to transfer over. And kind of going back to your original question, Royden, is this the ideal number of degrees of freedom? And I think if you're going to minimize it, absolutely. It's like that's about the bare minimum that you would go to, which is fine. They actually, again, they added some that I wouldn't have thought of adding, but I think it's interesting for emotional reasons to be able to, indicate the status, with the eyebrows. It's like, well, that's two, but those are really small actuators, so it doesn't matter. I think the other thing is funny is the name, because the company name is Fauna, which means animal, but the name Sprout is basically from flora. So you got the flora and the fauna there.
But I don't know if it's in America as well, but Sprout is it's a cool name, a very cute name that you'd call your kid.
Yeah.
I don't know if it's the same in America, but it is in English.
Yeah. It is.
So yeah, but it's fascinating to see. Gustav, do you think you or your hospital that you work at, or any hospital, would want to, maybe for a children's hospital, want to get a bot like this? Do you think they'd be useful?
Yeah, so there are these like caretaker bots around that I haven't really seen in Sweden at all, really. Mostly in Southeast Asia, and playing around with them. So probably not. I mean, it would be in the children's hospital or maybe in their play area, but it's not there when it comes to actually helping out in healthcare, I'd say, aside from giving some relief to the kids or playing. But I think we would need something more for it to be your nursing bot type of a deal.
Right. And for my audience, for my regular viewers, if you're surprised by Gustav's look, believe me, that is Gustav. It's another avatar of him, but it is the Viking from Sweden.
Yeah, well,
we need to run the campaign now to get him back to his regular look.
Yeah. Give it a few days, it'll be
back. Yeah. All right, so let's move on. This is a really interesting development, and I think this is the next level in doorstep delivery. Rivr Tech is using quadrupeds to deal with real problems in the world, and one of them being doorstep delivery. And of course, our very own Scott Walter had a very humorous post where he says, "The jig is up on this gig." Where did you find this? This is phenomenal.
Yeah, I didn't find it. I actually shot that. That's off of my phone.
Oh, it's in Switzerland, right?
Great camera work.
It's in Zurich. Yes, it's in Oerlikon, which is just outside of Zurich. Anyone who's been to Zurich and you take the train to the airport, Oerlikon is halfway to there. And it's sort of the tech startup center of Zurich. It's where all the, let's say the ETH students, when they get kicked out of ETH to start something, they end up over there early on. So everything's there, the ETH Robotics Club, everything. And there's a bunch from there. And I had a visit at Rivr. And the other post that I kind of made, you might want to bring up Gustav, or sorry, Rock, is I'm still jet lagged, okay? So
it's the same like when I don't have the beard.
These guys literally eat their own dog food. Okay, so you got a robot dog that does delivery, and when I was visiting, we did an order. So we ordered some food, and these guys were actually on the wrong side of the railroad tracks. So you get the main train station that goes to Irving, and they're on one side, but the town center is kind of on the other side. So in order to pick up anything, the dog actually has to go over. So you're seeing there's a ramp. So it can either go down the ramp like that, or it can go up the stairs. But just for kind of safety reasons, all right. But the thing about a train station, you don't realize it is the ultimate testing ground for pedestrian behavior. You've got every kind of pedestrian there. You got guys on bikes, you got guys on scooters, you got people that are rushing for their train, you've got elderly people who might be a little bit slow, you got people with, with backpacks and luggage and everything else, and they're coming from all sorts of directions. They can be really chaotic and hectic. And it did a splendid job of being able to navigate all of that on the way over and on the way back. And as we were tracking it and going around, I filmed that. And there's like this really weird, poignant scene of seeing, the human version of Just Eats, along with now the robot version, passing each other as they were going through. And I couldn't come up with a caption for it. I mean, literally, I was like trying to think, it's like, well, what is the best caption for this? And when I asked AI to caption it, it came up with all he said, I thought were just lame. There was just some kind of poignancy about seeing something like that, realizing that here's how it's done now by people and how it's got to happen. And almost like the shock value that he's going up, and suddenly he's like shaking his head, wait a minute, what did I just see? Going on by.
I saw the future pass me by.
Yes,
the
yes,
funny
exactly.
thing is that they're from the same company, right?
Yes, exactly. The exact same company. It's Just Eats. So they have a contract with Just Eats to be able to do it with the robot. Now it's just in that area. You can't do it in all parts of Zurich because they're getting the right of way for it to be able to do it. Now the one thing about this dog is it can go pretty fast. I think it can go up to maybe 30 kilometers per hour. And it's just the restriction. So it's not like these much slower sidewalk robots that you see in LA and other places that have just kind of failed the test because everything has to be flat and they go very, very slow. So this bot is able to hit all kinds of terrain. I think there was like 2 other sidewalk delivery companies that have tried to do Pittsburgh and they all failed. This is the only one that was able to succeed because they're really designed to be able to handle very punishing areas. And then the other possibility is if they can use bike lanes and get the allowance for that, it's more than the last mile. Because whenever you do the calculation for most of these side bots, they are so slow that the delivery rate is going to be like almost no more than a mile. It's very different than DoorDash, where people can get in a car and cover a much wider area. So if it's too slow, the economics just doesn't work out. So this is the one that is actually able to makes a little bit more sense because the possibility of them going a lot faster. Now, even though that's out of Zurich, ironically, that is the unit and not the one that is from Swiss Mile. But that's basically what they're using for prototyping purposes, and they get something else in the works. So they're definitely one to keep an eye on. It's really well done. There's no doubt about it, and that's going to be the future. And it was interesting to see the reaction of people in the train station when it came back. Suddenly, when someone was like, "It's a dog! Look at the robot dog!" The cell phones are on. Yeah,
that's nice.
But I hope they put the lid on the soup very tight because it's
Right.
quite shaky, this type of transportation.
Now, this is prototyping, and it can be used for any kinds of delivery. Food is one of them, but it could also be done for postal. If you go to their website, you will see there's various forms of delivery, and they do some package deliveries. And let's say one of the ways that they deliver the package is rather humorous. It's so humorous that I actually got a chuckle from Elon because Yes, you either take it out or it kind of drops the package in a particular way. So it's a little bit of
Oh yeah, I
scatological.
remember that. Yes.
They're solving that problem because a lot of people just kind of were like, "What about my wine glasses that might be in there?" Something like that. You're just going to
Okay,
drop
so
it
when
down.
when I saw that, I thought that was AI.
No.
It's
It's
real,
for
huh?
real.
Okay.
They put that in there literally as like an Easter egg of some sort, just to get kind of humorous chuckle, and that's
Not the
because they're
part you want to
prototyping
see
on the
coming out.
existing platform. But all those things will be resolved in the future. That deliveries will be able to be done very gently, and it's not just food, but it'll be all kinds of deliveries. So this is the kind of thing that companies that are in logistics would find very interesting, to be able to do that last mile. And they've shown that the last mile is not necessarily these things, but using something like a Zoox, which just kind of comes on in and suddenly the door opens up and like 4 of these dogs just scamper out and do everything with zip, we come right on time. So I think they've got a pretty successful, really good model because they've solved what I would say a lot of the technical issues that we've typically seen. And this, wheel bots with legs is the way to do it. We keep saying, "Oh, you got to use wheels, right? Those wheels will get you there a lot faster." And then, what about steps? It doesn't get there. It's like the problem is that wheels need a good suspension system. And once you give them legs, they have the perfect suspension system that they can handle any sort of terrain. And suddenly, you no longer have this argument between legged versus wheel. Like the answer is like both.
Yeah. You remember, guys, just a couple of chats back, we were talking about bot form factors and the predominance and almost overwhelming majority of bots that we see being developed are all in the humanoid form. And I asked you guys as a why. I think Merta, this was your bot poster, that chat, and I was quite a bit disappointed that we weren't seeing enough of innovation and enough of real world usage of quadrupeds, and now we do.
That is true. That's a very
So
good
much
point.
can be
But
done.
regarding what Scott said, so this is a unitary go-to, right? I think they call it go-to W or something. And then so the same demo that this guy had as like climbing stairs and stuff, Unitary had it also the same.
Yeah.
But I'm wondering, what did they solve here technically? Because if you look at this cargo up there, it is still tilting up to like 30 degrees or something, which is not so beneficial. And also, I don't see
Yeah,
any.
and the packages inside are being rattled around for sure.
Yes, exactly. So that's why I'm wondering, like, if we want to see this company as something that is solving a business problem or a service problem, rather a technical problem. Because the technical problem, it seems like it's being solved by Unitary already, which was having such a dexterous or agile platform. But they put a box on it, but then we see that the box has a technical issue that is not being solved. So that's the only part I'm a bit cynic here about that.
Yeah, this is a development platform for them to be able to prototype and improve it. And from that, they've learned a lot of things, and they won't be using this bot going forward. They will be using their own version that solves a lot of those technical issues. And so I think they also had to put a lot of policies in there. So they had something that they're able to build on top of. And a lot of things they've learned, of course, is how robust the system is. So they've had to design around that as well to make sure it survives. And so there's a lot of things that they've learned, and I can't discuss any further. But they're going to be coming up with something different.
That is great. The other thing I wanted to bring up here, maybe it's a bit of side discussion, but I would love to hear your opinion. So I was working on a robot's capex and opex calculation, and I got to realize in a 1-year timeline, if you have a service robot such as this, it's much cheaper if it's totally autonomous than operated by human. So in this context, I've seen most of these companies with these platform, they are having it teleoperated, or at least there's a human somewhere who is watching it basically all the time that is running. How was it? Did you and also the same company, they had a version that had the arm on it for package delivery. it was last year or something, and I saw that there was a human actually standing by the van with a controller. Actually, it seems like they were directly teleoperating it. So do you have any inputs, Scott, if it is autonomous to a good extent, or no, it is still teleoperated?
It's mostly autonomous, with the teleoperators that are just to supervise to make sure everything is okay. And there's like a lot of regulatory reasons why they have to do that. And it seems that while you would still have sort of a teleoperator, the question is like the number that you'd be able to do. So that they'd be able to do multiple ones, so you'd be able to bring that down. And in many cases, the operations centers will be in low-cost countries to be able to do it. A lot of effort, of course, is going into reduced latency and everything else. In many cases, the latency is not as critical as like when you're doing a humanoid kind of teleoperation where latency is going to be really quick. In this way, it's more or less kind of supervising that everything's okay if it gets stuck. So I agree that you know, you're not saving anything if basically the robot is just an extension of a human. It's like, well, then just go ahead and employ the human in the first place. But if you've got a multiplier factor there of like, you know, 2 to 1, 5 to 1, 10 to 1, then suddenly it does start to make sense.
Thank you.
Yeah, and the other thing is that you've got to be able to find that these bots can be used close to 24/7. And the thing is that when it comes to food delivery, in many cases, especially these much slower sidewalk bots, they're lucky to get maybe 4 runs in during a mealtime. And then, if they're not even doing breakfast, then they might have like 2 of them in there or something like that. So you're hoping to maybe get 10 a day. And it's supposed to be cheaper than doing a DoorDash delivery, which might be what, $4 or $6 or something. They're like small numbers that are on there. So you look at it and say, oh, this bot is maybe collecting anywhere from $40 to $50 a day. And then you start saying, how long do you have to go before this thing gets paid off? And so if these bots are costing $50,000 or something like that, that's a long time. So the cost of these bots has to get down in the order of 10,000. And you've got to make sure that you aren't having to then pay an operator, even in a low-cost country, $5 to $10 an hour, which at that point, then the business doesn't make sense. So they have to be autonomous and they have to be fast enough so they can get the deliveries, because if the round trip time is a half hour or more, the meal hour is over. You want these things to be quick. And then if they also can do things between it, which would be postal delivery and, let's say Amazon fulfillment center kind of stuff, then suddenly you get enough utility out and they start to make sense.
Yeah.
Otherwise, they're dedicated to just college campuses and very, very high density urban centers.
Yeah. And there's also the risk if someone orders curry for lunch or dinner, you're probably going to give them a refund because it's going to get spilled along the way. Scott doesn't know curry.
Maybe, but then again,
curry. Scott, you know curry.
I know curry, yeah, but it's
Okay,
all about the
good.
packaging. Yeah.
So is the drone?
I know a good vindaloo and tikka masala
nice.
and everything. Don't worry.
Nice.
But wouldn't the drone be better? Like a packaging, like Amazon's big.
Well, zip line, that's the one to be looking at, because they're looking at that. And so it sort of depends. China is a special case with how their urban centers are set up, that they're using drone deliveries in these areas that go up to the apartment buildings. Because a lot of problem with the delivery dogs is they can bring it to the doorman, but then how do you bring it up 20 floors? Someone's going to come down and get it. So now they're talking about really being able to deliver it there. Zip line is looking more in the case of like the urban sprawl that you have in the US, where you need to have those long distances that are covered very quickly, and then figuring out how do you deliver it. But in many cases, it's still like delivering in your backyard or something like that. So it's hard to tell what these different form factors are going to be. They'll all probably work together, that you just sort of pick the delivery service that makes sense for whatever is the delivery that you have to do. And again, you could augment these things with also like an autonomous driving vehicle. So for food delivery, because it's so random in nature and like so instantaneous, like the dog almost has to just go door to door. But when you're talking about package delivery, that's pretty much scheduled, and you get a bunch of packages and they're all in the same neighborhood, and the vehicle can just go up there, and then you can do that final door delivery. Because when they've looked at a lot of these things of saying that to change the nature of you have to come to the curb to pick up your package from the bot, it's just like the model doesn't work. It's like, nope, the bot's going to like bring it right to my doorstep and deliver it, or else it won't work. So you cannot change human nature to say they have to come to the curb to be able to pick up the delivery. It's got to go right to the door.
I'm also wondering, when is we can make a poll actually, when is the earliest time we will see a company comes up with a humanoid doing delivery?
Yeah.
Or
well, yeah, not yet. And I guess that would only make sense from a delivery vehicle. So that, you know, and I know there's some that are working on that. It's probably already been done in China. I'm sure it's been done in China.
For sure. But didn't we see that in the figure demo video?
Yeah. But that's again a proof of concept. It might be going to happen, but what it really will happen is like, I mean, I saw all sorts of these things of like the Rivians doing delivery, but now I've actually seen it in my neighborhood streets. So I'm like, oh, okay, so now it's a thing. But it was like the longest time that you were seeing these animations of like the Amazon Rivian trucks, and I'm sure it's like within the next year or two you'll begin to see that. Now, my understanding is that Rivr is doing deliveries in Austin right now. So that's like one area that when you go to Austin, you can check out to see whether you can get delivery from them.
But I mean, you would need the autonomous car as well. So, and at the moment, there's no one but Waymo and Tesla. And Tesla is not even there yet, but I mean, they have the tech. So I'm kind of guessing it will be Tesla with their humanoid who will really do the first humanoid package delivery, because when they're up and running, they have the whole package, so to say.
The whole package, pun intended, huh?
I mean, who wouldn't want a Cybertruck come over and a bot step out with your package? I mean, I would pay extra for that.
Stop already.
Yeah.
So basically, to answer your question, when are we going to see it? We want to make bets on that. I'm going to lay down the bets. Not this year.
Not this year.
I don't know when, but not this year. Yeah.
But while you were saying, just an idea came to my mind: a car seat that can have a charger that when the humanoid sits on it, then it will charge while in traffic or something. Because they have small batteries.
Not the foot charger that figure has, but have a button charger.
So it doesn't electrify human.
So is it like a charging plug coming out of the chair?
Where does it go?
Where's the plug? Yes, exactly.
No, you had to go there, man.
Well, you do bring up a point that the seats might be designed a little bit different for a humanoid than a human.
I think so.
Yeah.
Because
Just to make
right
accessibility
now,
a lot easier.
yeah, like right now when we are designing humanoids, actually, we are having a lot of issues with the panels to be able to hold the whole weight of the robot. Imagine the thigh panels. They are just plastic panels, so in many cases they cannot actually hold the weight of the robots. So and unitaries they can, because they're mostly aluminium, but that's another issue.
Yeah, because I don't think Optimus can actually set itself into the Cybertruck.
I don't think so.
The Cybertruck is the closest. The others are very hard. So every time that we've seen it in there, a person had to help get it in, because Optimus doesn't have the flexibility in the waist to be able to do it. And
that's why they have the
Robovan. Be able to do it in the Cybertruck, So you'd have the Robovan, or you'd set up a little bit different, that'd be able to kind of slide in and move around. And the other thing is that they don't need the creature comforts. So don't waste space, because the whole thing about a delivery van is that you want to be able to put as many packages in there as possible. And if you got all these creature comforts for Optimus, it's like, no. So
very good point.
It just be some way, does it need to sit, or does it just need to somehow get in there and stand or whatever?
Latch
onto the roof. You need some sort of seat belt or something, right? And this motion for humanoids is very hard, because we have limited ranges here in the shoulder, so they cannot take the seat belts and pull it on themselves. And these are I think these problems will be solved in 10 years.
Pull out like a roller coaster. And
exactly.
Agility showed a version with Ford a few years ago that they were working on that, and so they showed some like deliveries that were being non-autonomous, but again, there were more this proof of concept. But Digit basically packed up. It was like it was in the back of the van and shrunk down to be really pretty small, because it doesn't matter how comfortable it is on the ride, and it just unpacks itself. So I think you would put it where it's most needed, and in a way that's most compact as far or most volume efficient.
Okay, we've got a lot to cover, so let's move on quickly to a little more stuff from China. Interesting things happening there. The first of which is this. This was, of course, from the 19th of January. We're catching up after a while. So this is from the Xiaopeng CEO. He says, today, the first unit of our ET1 robot developed to automotive grade. I'm always confusing my American and English accents. Automotive grade standards has successfully rolled off the production line.
Aluminium.
Aluminium. It's not aluminum like the Americans say it. I say aluminium. With the team, we spent the entire day observing and discussing the details behind it. And I say nuclear, not nuclear. So he says, with the team, we spent the entire day observing and discussing the details behind it. This marks a critical step towards a large-scale mass production of advanced humanoid robots this year. ET1, is that the production version of the Iron Bot that kind of blew our minds?
I think so, and I was a bit confused why they're calling it ET1 because I thought it was always called Iron, and of course our nickname is Iron Maiden for the female version of it.
Yeah,
and we saw that Iron Maiden did come out and at a shopping mall.
Yeah, this is from Humanoid Hub, and
yes, and others. And as you see towards the end, she had the vapors from all the attention of the crowd, and for some reason just collapsed. It wasn't like a stumble and fall. It looks like something just sort of happened. I think at this point here that the system just decided, whoops, that definitely looks like a fainting spell to me, as opposed to some of the other collapses that I've seen. So.
Yeah, that looks very human. That's exactly how humans would faint.
Yes,
maybe that's teleoperated faint.
Yes, yes.
It's too hot and similar to the Tesla bot who kind of took his helmet off.
Yes. So they've all had it, and it keeps on bringing up the issue of the safety of these bots, especially when they're human scale.
Yeah.
And it's one thing to trip and fall, but it's another thing in many cases. It happened also to Engine AI at the CES that there was also a scene there, and then the bot just suddenly decided, oh, okay, I've had enough, and fallen over. And we have no idea what the cause is. It could be a variety of things. It could have also been just heating issues, which a lot of these actuators or a lot of these bots have, is that suddenly they pass some sort of thermal level, and then the system just decides to shut down.
Well, considering
at least it's not,
it could just be another virus.
Yeah. At least it's not flailing. I mean, it's falling very.
Yes. I was fine with the way that fell. It just went down. What concerned me about Engine AI is that it went down and looked like it was just fainting, and then the CEO tried to catch it, and then the process of trying to catch it, suddenly it started to flail. And Unitree is notorious for also flailing when it falls. It's not getting enough. So props to them. I mean, first, don't grab it.
I mean,
you need to CPR first, right?
I know the instinct is to try to grab, but that's a lot of mass coming down, and you don't know. It could have flailed, and then when it flails, you get punched or something like that. So I understand that everyone's saying that's like $100,000, $200,000 of equipment right there. I hate to see it break. Yeah, but a fractured jaw is also going to cost you $200,000, at least in the U.S. by the time they get all stitched together. I don't know what it is in Sweden.
$5 probably.
Yeah, $5. But yeah, unless you got really good health insurance.
But in its defense, it considering it's a female version of the bot, it fell rather elegantly.
Yes, again, yes, it's fainted properly. Yes.
We haven't seen the male version of the latest.
Who wants to? Come on.
Nobody's interested.
No, okay, I'm sorry.
Read the room, Gustav.
Nobody's interested. The male version might be a little taller because they were showing PowerPoints of the two.
Yeah.
And, we've seen the male one already, but that's the older version, Iron One.
That wrist is really messed up now.
Yeah.
She broke the wrist.
Well, but it's interesting to see that the CEO is saying this, that they've the first unit rolled out. I suppose a few would have rolled out by now, and we're discussing it. And it's interesting to see how China's marching ahead with this. So, automotive grade standards. What does that mean, and what is he signaling by telling us that?
May I add something here? What
Yeah.
I see in the design is not really addressing its being able to do any utilitarian automotive grade tasks. Like I see a lot of like limited ranges here, both with the fabric they've used and also how it's being designed. The size of the actuators are too slim. I mean, Scott analyzed it once, but they're too slim for being able to have like a proper payload. The dexterity of the hand, we haven't seen it much. I don't know if you have seen, but it looks like a complex hand, but we haven't seen really in action. And also the old questions: why do you need bipeds if it's in a car factory and so on? I have a feeling that they try too hard to push it on the marketing side and saying, yeah, we are an automotive company, we're having a robot, shareholders happy, all those stories, right? So, but again, cynical view. I don't know.
Yeah, I think the CEO pretty much admitted back in the fall that it's just going to be used for being a tour guide. Yeah, so the payload is like itself. That is not really going to pick up anything, and then eventually maybe they'll move forward to being able to do certain things. But right now, I think it really is just a showpiece. And from automotive grade, I assume they're just meaning manufacturing tolerances or the kind of components and everything you put in there. But even then, that would be kind of questionable. I'm not sure what the actuator mean time between failures are, that you would probably want them to be very, very high. And if they're just shooting for 10,000 hours, that doesn't cut it. So they might be producing a large number because it sounds like they're going to be ramping up. I don't know what that is, if they're looking for a couple thousand this year or tens of thousands. I don't know. Just because you can build it.
Maybe by automotive grade, they meant automotive cells. So it's car cell is selling is a part of the value chain, right? So maybe it's a salesman or women, and then
we don't know what that is, but you can build 10 or 20,000 of them, and if they don't have any utility, then they're going to stay in the showroom. So they have to have some capability, and that's what we'll have to see. So it's like you got to make sure there's the demand side. Yes, there's a demand. Everyone wants a humanoid in their homes since yesterday. The thing is, there are no humanoids that can do it. Until they are, people really aren't going to buy them. So you can build all these humanoids and say, we can put them in your home. But if they don't have the capability, nobody's going to buy it.
Yeah.
Few will.
They're not the only ones.
We will buy it and put it around, and then we'll tell everyone,
I would buy that car that is being sold by this robot, though.
Yeah. Having said that, they're not the only ones, because you have another report, this time from the South China Morning Post. And this is China's EU, I hope I'm pronouncing it right, has opened the world's first automated line for humanoid robot joints. Okay, so there's a theme emerging here, and I want to play this, pull this up on screen as well. So this is China's EU robot technology has launched the first automated production line for robot joints, positioning itself to capture growth ahead of a projected surge in humanoid robot shipments. The plant, based in Pudong, Shanghai, opened last Wednesday with an annual capacity of 100,000 units, with scope to triple output. 100,000 units? How much of this do you think is domestic consumption? How much is it of exports? Define units, because joints
what type of
units? It was confusing. I was seeing something like units and then 95,000 joints.
Yeah.
And by joints, I assume they mean actuators.
Yeah.
And the bots are consuming about 30 or more per bot. So take that and divide it by 30. And that tells you that's like, oh, we've got enough for about 3,000 bots, if that's what they're looking at.
So as I could get it correctly, this robot is building robot actuators.
That's what it looks like. Yeah. So and there are many companies looking to do something like this. Like Schaeffler in Germany is moving really hard into that area because they want to be both a component supplier of actuators to a lot of the humanoids. And they also want to be a consumer of humanoids, be putting in their same lines. And they're kind of an interesting company because they're really taking it on. I mean, most companies are kind of like, oh, let's wait and see how this whole thing's going to play out and be very conservative. And they're like embracing it fully. And so we see this other example there is that what can we learn by using the humanoids to start building parts of it? I mean, from the PR standpoint, it just sounds great. Oh, robots building robots. But that's been around for a while. Fanuc showed off their factory well over 30 years ago of their bots being able to build other bots or robots, industrial robots. So they've already been using their own production. This was the main thing here is this is more like the humanoids. When the humanoids are able to do, let's say, the entire supply chain, that will be really interesting. So I'm not surprised that they're going to be adding some value some places, but it's probably where they can do it. And there's a lot of value there. Even if, let's say, right at the beginning, the KPIs aren't there to use it, but then you just write it off as R&D. This is how we learn.
But if they can lower the price of an actuator, it's very valuable, right? Because the most expensive components of humanoids by today is just actuators, and maybe this way they can do it. Let's see.
And this is China we're talking about, which is basically the be all and end all when it comes to suppliers for global robotics, isn't it? Humanoid.
Yes. And again, any number that you see out there of how many humanoids we're building, you're gonna have to multiply by anywhere from 30 to 40, probably higher than that if you want to do all the actuators. Structural actuators is about 30. These are the big ones. But then you get the hands, which are gonna add like another 24 at least, or maybe more in there. So you need to build all those. So I think for the JPEG, they were saying maybe it had like 68 degrees of freedom when you look at all the actuators that are in there. So I want to build 1 million. Okay, there's 68 million actuators that you need to have. And then sometimes if you dig deep into the components there, that gets crazy. So again, if you look at Optimus is right now, and I think in V3 they're still going to have some linear actuators, but right now the V2 has about 14 actuators that are linear. And of those, you need 10 planetary roller screws per actuator. So that's 140 that you need. So if you're going to build 1 million, you need 140 million of those planetary roller screws. That's a big deal. Or screws, they come right out of the machine.
We're overdue on having a chat about that. And
but the problem is it takes 10 minutes a screw, okay? So it's like, whoa, we need 140 million.
What are those screws called?
Oh, wait a minute. That's planetary roller screws. So these are the planets that go in there. So now 140 times 10, that's 1.4 billion minutes that you would need per year to be able to hit a run rate of 1 million bots. Okay, divide that by 60, you get the hours. You're beginning to get an idea of like how much equipment you would need, or you need to find another way to be able to go from that 10 minutes on down. The reason why it's 10 minutes is because the worldwide demand for these kinds of actuators is so small, it's not worth putting the engineering effort into being able to get that down because no one is demanding it that much. So 10 minutes per roller screw is fine for now.
Yeah.
How fast will that change, you think? I mean, okay, let's ramp it up. We're going to build 140 million ones. Will it take a year to build out the capacity to do all of those within a year, or would you need more time? You will tell us next year.
No, it's possible.
Takes 1 year to calculate.
Let's just say, if the right people that are listening right now have an issue with that, I know a guy who knows the solution to this thing. He just needs, let's say, the demand signal to be able to do the effort.
Bring him on. Let's chat with him. Let's give him some airtime.
He will. But it could go from minutes down to seconds with the right engineering know-how. And again, it just comes down to.
Well, it has to, doesn't it?
Yeah.
If bots are going to scale, it has to. Okay, let's move on.
I mean, yeah.
Sorry, you want to make a point quickly?
Just there's another story that some people believe that we need to go hydraulic, the whole robot. And when you do that, then you have the hydraulic central pump, and then it doesn't really matter. The actuators are just pistons, basically. So
Is
you
this
can
like
just
clone? You're talking about clone.
that's one example. But there are like old Atlas, for example, was fully hydraulic, right?
Right.
And
right.
Sanctuary are still hydraulic for the
Exactly.
hands.
Yeah.
Yeah.
So
And
that
they
would be
come up
another.
with these micro valves. So the thing is, it's not like there's only like one pump or one motor.
Exactly.
You still need these micro valves that open and
Micro
close.
valves, exactly.
But
those
they're
are
not as complicated as an actuator, but there's still something that's like an on-off switch. And Sanctuary has developed, they get some patents, they get some really cool micro switches that are in there to be able to do it that makes it possible. So there are some that are working hard in that area that for now, people probably won't go there, but you never know. It could have a resurgence in the future.
True.
You just have to make sure that stuff doesn't leak.
True.
Yeah. All right, we've got a lot to go through, so let's quickly move on. There's another China-related news, but this is a bit of a clarification that came about a week or so back. Don't know if you guys have been following this, but there's been some sort of controversy over Unity's numbers for the last year. They set out this clarification on X saying, over the past month, many pieces of misinformation regarding our company's 2025 shipment volume have been circulating online. Unitree has never previously disclosed to 2025 sales data externally. We appreciate everyone's attention. In 2025, Unitree's actual shipment volume of humanoid bots exceeded 5,500 units. So the quantity actually sold and delivered to end customers, not order volume. The order volume is higher. Total mass production output of 2025 exceeded 6,500 units. The figure, aforementioned figures consist solely of our pure humanoid robots and do not include our dual-armed wheeled robots or any other robots. Currently, given the diversity of robotic forms, we suggest not to directly combine the numbers of different type of robots together for comparison. A little valuable.
So these are like the ones that deliver most bots of anyone. I mean, humanoids, right?
Almost,
Yes.
right?
And they're
That-
delivering 5.5.
That was
basically.
the understanding, but not by as much as everybody expected.
Oh.
True.
Yes, but I think at the same time, they're kind of throwing shade on some of their competitors who have wheel bots. So they're trying to say, which Mirdad has been taught over the longest time, is how do we define a humanoid? There's wheeled ones, stuff like that. So if you're going to take the trophy home for having produced the most humanoids, most people would say it should be the bipedal ones. And then there should be a different category that you talk about, those that are wheeled. It's not to throw shade on whether the wheeled bots have any utility or not. A lot of people argue they have way more utility right now in the early innings because you can deploy them a lot quicker. There's like all sorts of safety issues and stuff like that. But I understand that you need to come up with these categories of what we call a humanoid and what we call the wheeled humanoid. And I don't know, is the term going to be centaur or something else like that? Because I'm not sure if that's technically, like, if you really look at the mythological characters.
Okay, Mirdad, you're the expert.
But
I mean,
In the
no,
taxonomy.
I'm not really, but to me, a centaur is a quadruped with a bimanual.
Yeah.
Right?
Exactly.
We are aligned.
Exactly. That's a centaur. Then with the wheels, we have to, I don't know if there's any Grecian equivalents from mythology for that.
I mean, wheelchair, like
Disabled human.
disabled.
Maybe.
Yeah, it's like they are also humanoids. So.
Yeah.
So there. Yeah.
Skipping like Dave.
We're gonna get
But I have
banned
another
with our humor.
question regarding this. Was this number surprising for you? 5,500.
Let's see, isn't this similar as what UBTech did? Say, how many is UBTech claiming? Was it also them?
But UBTech, I think they are in that they have a lot of different versions. So they are including everything, I think.
Yeah. And I think that's what it might have been. And that's why Unitree was coming out and saying, wait a minute, you can't roll them all in. You kind of have to separate them out. Now, what's surprising is they said they delivered 5,500, but they manufactured 6,500. So it's like, what happened to the other 1,000?
I mean, the
Because
other
the
thing is
demand
that
is
I
there.
don't know if you experience, but if you order something from Unitree, it actually takes a few weeks of lead time.
Yeah. Oh, it's sometimes months. I know a lot of people that waited a long time for it.
True.
And they're kind of, so if there's 1,000 sitting around somewhere in a warehouse, maybe that explains it. So, or, it's still for like internal consumption that, 1,000 may be using for their own R&D and training or something like that.
To me, it was a very low number. I don't know. Should be more. Like, I know people around me who has either a quadruped or a humanoids Unitree, but I don't know.
Well, at the same time, how many Cybertrucks are out there? There's not a large number of Cybertrucks out there, but I see them all the time where I am. And so it only takes like, a small number, and you'd be surprised how much you run across it. Maybe not. So again, take that number and multiply it by 30. And there was a company, it's I think it was My Actuator. They put out the fact that they were coming up with a new factory for producing 100,000 actuators a year. And I just made some comment. It's like, we're going to need a bigger factory or something like that, because that just seemed like a small number, because that was like enough for about 3,000 bots. And one of the sales guys posted back to me. He said, right now, that's like more than enough. The demand is not as big as you think. And that kind of was shocking. I was like, what? Wait. So part of it is that they couldn't produce more, maybe because there's not enough actuator volume to be able to meet that demand. And at the same time, it seems the other way around, that the actuator companies are saying, we're not building a million or 10 million actuator factory yet, because we don't think there's that demand. So that was a rather surprising market signal to me.
Another thing I wanted to compare with was home vacuum cleaners. And I remember I saw this number from Only iRobot Roomba, which was kind of a large number, actually. If I remember, like 20 million units or something is sold. So
per year, or that was like over?
I think till now. Yeah, till now or something.
Till now. Okay, so that's over 20 years.
Sorry, till 2024. No, I checked.
Okay, and I think they started selling them with early 2000s, but I think that was really small numbers.
Yeah.
So maybe basically the past 10 years is really where they picked up.
That's interesting. It goes back to our claim that we were discussing about, some people claim that we will have like, 100 million humanoids being sold by this certain year. Yeah. And now maybe with this number, we can kind of...
It depends upon the utility. Of those 20 million, I bought 2. Probably there may have been some other people that, bought them first around 2010 and then again 2020. Obviously not enough of us did, because they went out of business. So that's just one humanoid company. And again, it comes down to the utility. It was okay, but not enough to really move the needle. It was more or less the early adopters that did it. So how many households do we have in the US? I think we've got 300,000. We got maybe 90,000 households or something like that. Not 90 million. So, you're muted.
Yes, offices are big markets also for home vacuum cleaners.
Okay. So there might be some of those, but yeah, still it's not there. It comes out of the utility. This idea that eventually it's going to be one per person, and wherever this thing here, there's more than one in my household. Trust me, when I check the bill each month, it's like, wow, there's a lot of devices on there. And so that's because the utility is so high, it becomes more one-to-one. When you're doing like one to household, then it kind of goes down. Then you're looking at volumes that aren't going to be more than cars. In cars worldwide, what's the worldwide sales for cars? Is it 40 or 50? Maybe 50. I'm trying. Usually North American automobile production volumes are like around 17 million or something like that. So
but it's also the business side of it, right? A lot of cars are just owned by companies, and
but that's actual production. So every year North America is producing about that number. I assume Europe is about the same, and then you've got Japan and China. So maybe like 50 million is sort of the current demand. So would the humanoid bots exceed that? Potentially, because we're looking at factories, so you really have to look at workers, so like how many people are employed. So that's usually the TAM everyone goes from. It's like this is how many people are employed. We're going to put them all out of, we're going to put them all on the unemployment line. So therefore, this is how many are going to be there. But the other way to look at it is the number of equipment you have, and even then you have to be careful. You just can't say take the number of workers and it's a 1-to-1. It could be a 1 to 10. First of all, I can do 3 to 4 shifts. So that means 1 robot replaces 4 workers. If it's like a true 1-to-1, and then if the bot is like superhuman, then it can do twice as much as that person. Then suddenly you kind of go there. So that
probably we need 50 per hand surgeon, like in different professions.
Yeah.
Different,
level, you'll need 100. But it's the balance between like we don't really know which actuators we want, so therefore the companies don't want to build them, because even if someone says, "Oh, we're gonna build 10 million bots next year," but we're not really sure what actuator we want. Is that a problem, or is it like that?
Yeah. Oh, that's a basic. Like I said, right now, just the bifurcation between whether you have rotary or linear, they're completely different supply chains, and if the signal isn't out there for linear drives, no one's going to invest in the tech to be able to come up with what you need to be able to push them at high volume. And this is kind of this chicken and egg problem that you have, or is being able to resolve that. We know we're going to need rotary, so everyone is like putting a lot of effort in the rotary. But when it comes to linear, a lot of companies are investigating, but they're balking because they don't see the demand there. Without commitments, without them coming, someone coming in, and saying that we definitely are going to put out a requirement for this many over this number of years. No one's going to go ahead and do it, because right now it seems that Tesla and Xpeng are the only 2 bots that are really leaning into having linear drives. Everyone else is going rotary for now. That could change. You don't know. It's like everyone start testing them out and begin to realize, these things don't have the durability we want, all of these things that we have to kind of change in it. And then maybe they see that Xpeng and Tesla are somehow having success with linear actuators that they can shift. But right now it's not there. So that is a very important, and that's just like one example. And I'm sure there's like other examples within the bots.
So everything that you have just said, Scott, it just puts in perspective how far we are actually from seeing bots on floors of factories and in the households. Is everyone getting ahead of themselves?
Yeah. Everyone's ahead of their skis. There's no doubt about it. I'm trying to make sure people temper their expectations. I am long-term bullish, no doubt about it. Long-term bullish on humanoids, but I am short-term a bit bearish because everyone is getting the expectations that they're going to be in their homes tomorrow, and it's really not till 2030 that I think you really start to see that a lot of the issues that we have are going to be resolved. We're going to see, some exciting things happen in 2026. No doubt about it. But you've got to be very careful and temper yourself. I'm like, oh, does that mean it's in my home tomorrow? It's like, no, there's still a lot of work that has to be done, both from the AI front, as well as the design front, as well as figuring out the supply chains that you'll be able to do it to be able to bring the prices down. So, it's definitely a very interesting time to be around. We're going to be seeing a lot of these videos now. Loading and unloading dishwashers is pretty interesting. We see that a humanoid can do it, but loading a real dishwasher and unloading a real dishwasher
direction you want to go in.
Pardon? Yeah.
If you can't decide which actuator direction you want to go in because you haven't tested it enough, you haven't had enough of cycles to test it. And then you can't place an order to the supply chains to feed you. The supply chains are not going to kind of preemptively go one way or the other. And if there's no supply chain set up, then what are we even talking about?
It's natural selection, I think. We need to wait. We need to have enough companies. They need to try enough, and we will see which one we will. And that's why we have so many companies, because only 10% of them will remain, right? So I think could go that way.
So Elon's statement that this year they will have some in their factories, they probably already have, but let's say that they're actually doing something. And next year consumers, is he talking company consumers and not like homes?
No, okay. First of all, from the statements that Tesla made in the earnings call, is that there are no Optimus in any Tesla factories right now. They have not been doing any meaningful work. They've been there just for testing and R&D. So they clarified that whatever the expectations were, Optimus has fallen way short of the timelines that everyone expected and fallen way short of the timelines that were given 12 months ago. 12 months ago, there was also the exact same statement that there would be a lot of Optimi in the factories at the end of the year. Now they're ripping out the X and S line, which I always thought was like the perfect testing ground for Optimus, is that they should have kept the line running, and rather than saying this is where we're going to put the Optimus line, that's where they should be doing the actual testing, because that is the line, let's say, is the least advanced and needs the most human intervention to do everything. So that would have been perfect. So it's kind of a shame that they're tearing it out. They're ramping up for a line that could potentially do 1 million, but again, it seems to be getting a little bit ahead of their skis. They are not going to be producing 1 million Optimus robots next year. The statement, this is where you'd be listen to what is actually said. What was said is that by the end of the year, they will finally kind of get the line starting to come up, which is projected to be able to do 1 million at some point in the future. They're designed for that. It was also made very, very clear. So it's just going to be starting, and the ramp will be very slow at first. Those are Elon's words. It's going to be very, very slow work. And remember, the Cybertruck, the ramp is still going on. It's been very, very slow. Berlin is still very, very, very slow. So do not expect that in 2027 there will be 1 million Optimus. And they are building a facility in Texas, which is projected to be able to do 10 million Optimi. But that's going to be a lot further in the future. It's also going to depend upon supply chains and everything else. So really temper what the expectations are. Elon also said regarding the sales of Optimus next year, every single statement he said was prefaced before that would probably.
Yeah.
Probably.
At least I got my S before they tear it down.
Exactly. So just remember, every one of them, he is not saying definitively it's going to happen. It's what he is hoping, is what the expectations are.
Okay.
Because this time last year, he was saying we would probably have 10,000 Optimus, the line producing 10,000 at the end of 2025. That did not happen.
Didn't happen.
Well,
Okay,
well,
so
if
let
that's
me
the
ask you
case,
a
I can
question.
say tomorrow I can build a humanoid robot that costs like 1,000K. Sorry, 100K, and then it can do everything. It's the most generalized thing, probably. So
yeah, you probably can.
Probably, probably can.
Tomorrow I'll let you know, but
Exactly.
Let me ask you a question, both of you, Scott and Merdad. From an engineering point of view, do you think that the first version of Optimus Gen 3 will be the one that will be mass produced, or is it going to be version 2 or version 3 when it's scaled up?
Okay, so we have a long timeline. There's a long way from 1 to 1 million. Usually what happens is that you get production volumes that might be 1,000, and then 10,000, then 100,000, and then 1 million. Okay, so you cannot accelerate that quickly. So you are looking at a scale of in the best case 3 years, more like 4 or 5 years. In that time frame, you are going to be having a lot of new versions and revisions. So the expectation is that the design they have right now for V3 will be the architecture that they believe that they can then build on and start to mass produce and learn how to do it. So they're starting to scale the line around whatever that design is. But I don't think it will be the one that they'll produce 1 million. It will be like V4, V5, V6. So they're all pretty much coming up with a new design every 18 months. Let's say, some are trying to do it 12 months, but basically about every 18 months, there will be a design cycle in there. So I would say it would be the version 5 or version 6.
Because there's also the chip to consider.
Yeah. I don't think it, AI4 is not the right chip for Optimus. It still was heavily designed for full self-driving. And it sounds like with AI5, they found out enough of what you got to do to actually have an inference chip for a humanoid bot that they can combine the two together. So I would say that those timelines are more like AI5, more likely AI6 when you start seeing the million run rate.
Well, AI5 isn't coming this year. It's going to come towards the middle of
Yeah. So again, this is, if they've really changed the design a lot, which is what it sounds like, there's going to be teething pains. It's going to look really nice, it's going to do a lot of stuff, but it's still going to take a while before it gets going. And the thing is, there's always like refreshes and mid-cycle updates and everything else.
Yeah.
So whatever they may be calling that first one that they have, within 6 months, they'll have made a ton of changes to the thing that you won't even notice it. If you look really closely at some of the different Optimus versions, version 2, you can see some slight changes that they made here or there on a couple of things, even though overall it looks like it's the same bot.
I can have the same opinion with the tangent here. So in my opinion, the mass production starts when we have the first, let's say roughly 1,000 customer. And then after that, you can talk about mass production. Before that, mass production doesn't make any sense. It just basically means that you have built a product that you haven't validated with anyone. You haven't really dig into the engineering problems at all. We have so many engineering problems existing right now in humanoids, and we have much more than that uncovered. We don't know what these issues are until we have deployed it in the field, and that hasn't happened with Optimus or a lot of other robotics. Maybe Unit 3 is actually more ahead because they have deployed 5,500, right? So now I think Unit 3 can actually talk about mass production of a range of millions. But before that, anything we say would be a speculation, I would say.
I mean, the development or evolution of the bots will probably be similar to the car or Starship or whatever. I mean, the Tesla Model 3 that came out in whatever, 17 or 18, is not the same as the one in 22, but it still had the same name, there was no official, this is the new model, but there are a lot of changes in it.
I mean, when I was in the car manufacturing, one thing I learned is that never buy a car the first 6 months that it being introduced, because that's where they want to do all the debugging and see what happens, get the feedback from customer. Then they have a second batch, usually after 6 months, and that's the batch that you need to buy, not the first 6 month batch. So being early adopter in car manufacturing is actually a very big mistake.
Yeah. They need to close the gaps first.
True. Another thing I wanted to add here, actually, regarding what Gustav said, that if we want to get a twin product for humanoids, I've been thinking about it for a while. I don't know how correct it is, but it could be drones. Drone industry had a very, very interesting similar path to what humanoids or robotics is going through now. And one of the most important ones was that drones, they didn't really have a perfect, clear application at the beginning. They were like just drones. They were cool. And then the application was adopted by the adopters. So somebody was doing photography, they used it for photography. Somebody was doing wedding photography, they used it for that sense. Somebody was doing scanning or geology, and they used it there. Somebody was using it for, So that's how I see humanoids being adopted, actually, when it comes to application. But first, we need to build that general enough platform, which in drones, they could do it. The same conversation about actuators that we had. In drone, it was the same actuator. You know the company T-Motor, right? T-Motor was the one who stole this patent of brushless motor from MIT, and then they mass-produced it, and then we had a boom in the drone industry because of that actuator. Same story, actually, in robotics. It was the QDD actuators, which is based on the brushless motors that we have in the drones. So there they could solve it this way. Here, I could see the same path, actually. That's why I think automotive is not a good twin to humanoids. Automotive has had like 100 years background, but drones are more recent, and I think that's more tangible.
Yeah, I agree that at first drones were, let's say, more like entertainment. It's like, for weddings, for filming and sporting events, and a few other things. And then it started getting adopted by a lot of people. So realtors, for example, they use it because whenever they're getting ready to present a property, they want to go around and get all the shots of publicity.
Exactly.
Anyone that's like insurance companies.
Agriculture drones.
Yes,
Yeah.
when adjusters come out, they need that right away to do the fly around of your house to see whatever damage might be there, or not from personal experience. And so, yeah, there's a variety of professional uses that you start seeing that they go in there. No one dreamed of at first. At first, it was just pure entertainment. Oh yeah, you can put it up and go around and have all sorts of fun. Just basically just driving it. I mean, that's the reason the cameras are on there, so you could fly it. It wasn't so much that you could actually do some, true surveying until people realize, hey, it's useful for that, like and others. And it'll be the same with the humanoids. We don't quite know what the applications are going to be yet, but the market will figure that out.
Yeah. Okay, let's move on. Closer to China, we've got a Japanese company. A shout out to CyberRobo. It's called Donut Robotics. It's unveiled its first humanoid robot called Cinnamon One. Anyone getting 1X Neo vibes here? Or a cross between 1X and Asimo? The Honda
A
bot?
little bit. I think it's your standard bot, but they've just put good coverings on it. So I don't think it's tendon-based or anything like that. It looks like it's normal kind of actuators. I had a friend who just came back from Japan, and he says that Japan, they're humanoid crazy right now. And I'm glad to see it because there were two countries that seemed like they were sleeping on humanoids, and that was Japan and Korea.
Yeah.
They have big traditions in robotics. I'm like, where are they? We're hearing it from everyone else. And it seems that they were busy cooking, and now we're starting to sort of see them come out. And so that's a good thing to see, is that Japan is also bringing some humanoids on there. And it's really hard to tell between that and stuff like that. I can see kind of a far waist, I think, that's got a nice anhedral angle in there probably, but without the coverings coming off, they probably knew I would do a frame-by-frame analysis, so they covered it.
Just
like an
wondering,
off-the-shelf handle or something.
yeah,
with the glove on it.
what is also with donut and cinnamon, like kanelbulle kind of a thing? Anyway,
Does it come with Reese's?
it's a Swedish thing. Yeah. Anyway, so the idea of putting like a clothes on, it's very the Humanoid, the UK company, and the face, I agree, is very Asimo at some point. But maybe they kind of got all these blends of what Japanese people might like and what could be unique, because nowadays, if you are designing a humanoid, you have to make sure it looks unique. Otherwise, it wouldn't be seen, right? It wouldn't come to this podcast. So that's I think.
But if you look at the specs, it's got a height of about 170 centimeters, weighs about 70 kilograms. Interesting, they say the first mass-produced bipedal humanoid robot from a Japanese brand. Mass-produced already?
Is it mass-produced?
No. We made two.
In Japanese culture, there's a different definition, probably.
Yeah, I don't know. I mean, so I've used Google Translate to English, so maybe something got changed there, but.
So it's for internal markets.
Possibly.
It's very Japanese, right? When you look at it, you're like,
Also the white outfit. With a lot of factories, that's kind of like the standard attire. And it gets really confusing when you go there and you try finding your contact there. And they're all wearing the same white uniform. And like,
true.
Also, that face, or is it a visor? It looks like more like what you wear if you went fencing.
True.
It's like the what's it called? The brushed metal. It gives me Power Ranger vibes. I don't know why. It's like this. Something about the brushed steel.
And that's a very pronounced battery pack on the back. It's almost
it looks like a space backpack.
Yeah, and it looks like it also has the RSU ankle and everything else, which is why I think it's standard actuation.
But I am a bit disappointed. I mean, at least as a biased, or what do you call it, Westerner with a lot of whatever. Sorry, I forget the words. But I mean, the Japanese, they should make really cool robots. They should have
exactly.
like wings and
Yeah,
should
yeah,
like
yeah.
tags
Yeah,
on their
but
back and like.
I think they
Like,
just,
come on, man! You made this 25 years ago already. So
Yes,
why
yeah,
don't you do
yeah.
I
it?
know, right?
Just copy paste.
Like yeah, it's I don't know. I think it's part of the culture now because there's so many examples of Japanese technology that used to be world leaders, like Ricoh. So one of the first, um, I wouldn't call it professional grade, but one of the first really high quality personal 360-degree video cameras was built by Ricoh. It was called the Ricoh Theta. And then the 1X, which is again Chinese, they came out and they completely smashed Ricoh. And Ricoh just had so much of a lead over everybody else, and they just sat on it and they did nothing. So I wonder if they're doing the same with robotics.
And then let's not bring up Sony.
Oh yeah,
Oh yeah.
I mean, think about that. The 90s and early 2000s, Sony owned everything, VCRs, TVs, that whole ecosystem. If you want all those things to plug and play together, related to Sony. And then it just seemed to disappear.
Now it's just the PlayStation that they.
Yeah, yeah.
Or do you remember JVC?
Oh yeah.
It was a lot everywhere in every household, and then the company just was shut down for some reason. I haven't seen anything.
That's the old Victor company that came out of RCA. So I mean, storied history that went way back, and when we kind of ran into trouble in the U.S., it was bought up by the Japanese and reinvigorated. So I think it's like what the Japanese Victor company.
True.
From the old Victrola, yeah.
I still have a stereo of them in the garage. That works.
Yeah. Or we had the Aibo, right? The robot dog.
Mm-hmm.
And there is a community on Reddit actually pretty big for Aibo owners. So they are like the ones who own it because they don't produce it anymore. So it's very valuable now for the ones who own it. And they all have issue with repairing. So there are some other businesses created guys who repair Aibos basically nowadays. It's interesting.
Yeah. Ancillary companies. The ecosystem is growing.
Yeah.
All right.
No, I hope that they undress it and then underneath you have some kind of Gundam style transforming robot.
But that was Korean, right?
Gundam was Gundam Korean.
Gundam was Korean.
It is.
Put my shame hat on.
Okay. All right. So let's move on. We've got another interesting topic to discuss, which is, and this is a shout out to Ilir. Now all you need to make tactile sensors is a 3D printer, magnets, and magnetometers. A new tactile sensor called eFlesh, with a simple working principle, measure deformations in 3D printable microstructures. eFlesh is this interesting new startup, again out of New York. I have to say, Scott, I'm with you. I'm surprised by the amount of innovation coming out of New York. So, young guy who started it, Indian origin guy, studied at one of the IITs in India and then went to America, and he started this. It's a fascinating concept. The fact that you can democratize this.
It feels like I've seen it a few years back, so I wonder if it's just that it's been further developed or something. But
yeah, I would think this is right in your wheelhouse, Gustav, with all the 3D printing that you do.
Yeah, with the printing. But I mean, it's still quite big. I mean, it's not a fingertip-sized production yet, but I mean, it is. Sorry, my bad. Holds the egg.
Yeah.
I mean, how high def could you get this, or like?
Yeah, it may not be a question of how high def it is, but the ability to be able to tell where something's going to be in contact. So again, turning your robots into more compatible. So there's always been a problem with the cobot in the definition of what is a cobot versus industrial bot. And then they discovered that, the problem is not the cobot, it's the end of arm tooling and everything else in the environment. So if you have your cobot with a samurai sword, I think we could all agree it's pretty dangerous. And for the most part, a lot of end-of-arm tooling is almost the equivalent of a samurai sword. That is pretty dangerous. So now they're thinking like, well, how do you put padding around the end-of-arm tooling in the first place to make it safe? So so A3 has basically said, we're no longer using the term cobot, we're using the term cobotic cells, because that's where it makes sense. Is like the finished product has to be safe. And a lot of it means coming up with something to give you the protection. And so it looks like this might be some way of being able to kind of wrap things around and not just put bubble wrap, because all bubble wrap does is make it soft and make sure it doesn't hit, but that when you come in contact with it, it's able to register, hey, there's some contact coming on over here, maybe we should do something about it. So like what you're seeing there looks to be a pretty interesting way to be able to safeguard people from what could be rather lethal equipment.
Very true.
And,
One thing I can add is that there was a time that I was being contacted with a lot of companies or labs who were building tactile sensors, and they had all different configurations, and a lot of them were very similar. And one of the things that was kind of trendy and everybody was trying to achieve was the shear force. So not the direct pressure or perpendicular, but just shear force. And it's very important for a slip, for example, when you're holding a cup and slipping in the hand.
Yeah.
And not many companies had it, but I was very surprised that they saw that they have shear force also covered, which is a big thing. But one thing is that is also very important in this area is the form factor and size. So for example, for fingertip, we need to make it even smaller than what we see here, actually. So I don't know how small can you make it given the resolution of
So
the printer and everything.
that's a perfect segue to what I wanted to ask you. Could this be a full body layer, sensory layer, right across any bot?
On like the whole robot or only parts that matters?
Well, the parts that matter all over.
I mean,
It could be, it could be all the external coverings and stuff like that. You could have something like this.
Yeah.
And I know Nura is using something as well that they're able to print on. It's much thinner that also allows you to do touch sensing so that it knows when you come in contact with it. So this is one method, but I know there are other methods out there as well.
True.
Yeah, of course.
And as Scott said, the resolution matters quite a lot. Nowadays, they have like very restrict specification that companies need for this. The other thing is that usually they have some sort of a driver or something, and we don't want too many of those. If you can connect all them to one driver, one small one, is very beneficial. So, but what I saw was that it's some sort of a modular system, so you need one driver per unit or something. Yeah, this kind of like, but it's a great product actually. I can see the day that we have more of it in the robot. But regarding your question, we still need, so it's not only touch, it's also like the whole haptic, something that can also, like you need the force torque sensors also, and you need the feedback from actuators to be able to actually understand the haptic properties of an object.
Yeah, that's important. But I suppose this could be an initial prototype, and of course, something to be worked on if there's promise in this approach.
Absolutely.
Yeah, I'm going to try and get this guy on for a chat with us.
That'd be nice.
Yeah. Cool. Any advice that you would give to anyone going down this path of trying to innovate with sensory layers, whether it's for specific parts of the bot, like the palm and the fingertips, or just whole body, let's say an e-flesh, to borrow the name from these guys?
I mean, I like the fact that there are different approaches going. So we have this really like actuator based, where you push on the bot and it senses exactly where you are. So that's a totally different like approach than actually trying to mimic the skin. It's just collecting the information you get from the back drivability or whatever you call it to infer what's being done. But then you would need something like Merda was mentioning with the shear forces. I'm not sure that could be done with that kind of setup. So you probably need something in the grippers or in the hands, perhaps also further up, depending on how you're carrying your things. And then perhaps also like the really fine detail. That's where I guess there will be the most problems. You don't want it to feel pain, I guess, aside from protecting, but you need to be able to discern really fine objects if you're gonna pick up something from a bag that you can't look into. Like I'm gonna pick up the paper clip and not the coin and not the needle. We can do that perfectly fine without even breaking a sweat. But with the sensors that these guys have, it's probably going to be a bit trickier. So you need
Very
something,
true.
I think, higher resolution than this for that type of activities.
I can continue along what Gustav said. There is I was thinking about the figure video, and I was wondering if there is an object that is very hot, let's say a pot or something that for some reason is hot. If the robot doesn't have any thermo sensor or something on the hand, how does it know? And it can pick that thing up, and the hands can melt basically, or something bad might happen. There's a reason that we have all those sensors within our hands, right? But regarding your question, Royden, I think one of the most important things is integration. So they need to consider integration of their system with existing robots. And many of them don't. Many of them, there's standalone systems. You can't believe, like, I was talking to somebody last week. I cannot mention the company. They built the same tactile sensor, and they are usually in the range of 3,000 to 15,000 volt. The tactile sensors that they have. So, and that amount of voltage, you don't want to have it on the robot, or there are a lot of limitations there. The other thing is the form factor when it comes to integration. Many of them are just making it out of lab, the biggest thing they can make, and when they want to minimize it, they face a lot of issues. So integration, I think, is kind of the main thing they need to consider.
All right. Interesting, fascinating. All right, so we've discussed a lot about bots on Earth. It's time to get into space, and we're going to do that with the U.S. Navy posting a few days back. The U.S. Naval Research Laboratory is advancing a new era of on-orbit satellite servicing, designed to inspect, repair, upgrade, and adjust satellites directly in geosynchronous orbit 22,000 miles above Earth. This robotic capability extends mission life and strengthens the space systems that support communication, science, and national security. Oh boy. Now, Scott and I and a few others in the past have talked a lot about bots in space. This is fascinating because it's something that the new space economy, with a number of satellites out there, has wanted for a long time, to extend the life of satellites and other for various purposes. It's fascinating to see this coming through. Scott, if you remember our chats with Ben and others, we've talked about bots in space. We've talked about form factors. We've talked about bots on the ISS, right? Do you see this as one of the most interesting steps in that direction?
Yes, and what I'm trying to tell from here is that these are the actual bots they're planning on putting out there, because it looks like they have gold foil and everything else on them. So there's some similarities to the Canadian arm that was on the space shuttle. Yeah. So and those bot designs are very interesting because they're operating in 0G. So the Canadian arm could not lift itself up in Earth gravity. It was really just able designed to be able to work in a gravity-free space, which meant, you know, the motors and everything else did not quite have the power, nor did they want it to have the power. They also moved really, really slowly, so they were telerobotically actuated. And the thing is, they did not want them to move very fast, so you had to be very patient moving that thing around. It's probably the same thing here, is that usually a lot of the configurations I have, this might be a 7-axis kind of symmetric arm, where there's a lot of these arms that literally can unplug it from one side and then go to another so that they can crawl around. So they're designed to be symmetric so that what looks like the wrist can suddenly become the waist. So it would go on, lock itself down on some structure, and what was the waist would unplug itself and be able to move around. And so more than likely, I think it probably has In this case, it doesn't. I'm not sure if it looks like that. It looks like the waist is going to be pretty much affixed right there, and you're just going to have a dedicated wrist out there, which is doing the manipulation. So a lot of challenges that you have in space. One of them, of course, is being zero G, which you think would make it a little bit easier. But you also have a lot of thermal issues here, which I think is why you see it's completely wrapped in gold foil. Because, a lot of the actuators we have in robots down here on Earth tend to have thermal problems as well.
I thought the goal was just with your present chief of the gold dome and everything. I like gold.
It does actually. Now it's actually not gold, but it looks like gold. It's a type of mylar which has a gold covering. I used to think that as well. That like the lunar module had that. And then I found out in a visit to get into space, it was like, oh, it's just it's a mylar that has a gold color. So evidently, like a gold color is much better at reflecting heat than silver, which kind of surprised me because I always thought like the things that are more silvery, more mirror-like are the ones that reflect the most. But you got to remember it's the whole spectrum of the wavelengths. A lot of the heat is actually in those that we don't see. So just because you're seeing like this kind of orangish color that's coming off of that, it doesn't really mean very much. So a lot of that is for being able to reflect away as much heat as possible.
I mean, looking towards the future with 1 million or 1 billion satellites to create our Dyson sphere or whatever around the Earth. I mean, it seems a bit big. Yeah. I mean, shouldn't you have like a smaller bot that's easily transportable between the different satellites? I'm still thinking for this Japanese robotic, it's like rockets on the back and flying around there.
I'm wondering what's going on because I'm looking at that and it looks like a Kuka arm to me, probably because of the color and also the proportions are about the same, which means, man, that thing is like really solid and strong. Whereas in space, I think the Canadian arm may have been, I think it was like cylindrical units and it could have been like made out of composites. So you do want something that's very light. There's no sense throwing up more mass than you need, especially when all you have to deal with is inertia, not weight. And so, the Canadian arm was grabbing the Hubble Space Telescope, which was like pretty heavy. But the thing is, all it had to do was like deal with the inertia of getting it to move and getting it to stop. It didn't have to worry about gravitational loading or anything like that. So you don't have to over design it. And looking at that, it does look, I was expecting it to be a lot thinner, but it could be that it is very light because you can get strength from a cylinder just by increasing the radius. So it might be completely hollow in there, but if you have a nice big radius in there, it'll have a lot of rigidity and strength to it that you normally wouldn't have if it was very, very thin. So that might be part of what's going on.
I'm not going to mention the circumference.
But I can emphasize on what Scott said. So actually, I was in a design process of a cobot, and one of the things is that you actually intentionally try to make it as heavy as possible in the base, like in the first J1 and J2. And then if they just take that and put it on for the space application, that sounds very crazy. It seems like we should have a specific cobot for space, which could be a totally different configuration and specification. But I don't know, maybe the market is not big enough that no company is building that, or I don't know.
Yeah, I would think so, unless, one of the things that comes into the design of these things is not what you need to have on station, but the strength and rigidity you need to get there in the first place. So these things are handling a lot of G's on the way up. In so many cases, they got to figure out how do we actually package it so it doesn't fall apart. And then, so it may be that they can start thinking in the future, how do we start assembling these things in space and bring them up? Not having to worry about the torturous flight it has to go through to get there. Because that's kind of a shame. I mean, it's like we're just talking about 7 minutes or so, and that's it. And after that, it never is going to experience that loading again.
Yeah, and then they have to test them on the ground, right? But on the ground, you need all those properties again. So
yeah, and what they do is they suspend them. They use all these cables and stuff like that to simulate zero G. Yeah,
I see. Okay.
By the way, we already have these cute little cuboid bots on the ISS for a few years now. They're the Astroby, the bumblebee, the honeybee, and the queen bee. And I think they've recently got a bit of an upgrade. Of course, on the ISS, it's microgravity, but they propel themselves around. And Scott,
just with fans. Yeah,
just with fans.
That's cool.
So there's so many form factors in space and so many use cases that you could have bots that has specifically been designed for specific use cases. Is that the way forward, or is it like Gustav was suggesting, a generalized bot, maybe just a human with a backpack, rocket back on his back, flying around? Or Optimus?
Yeah, you'll probably have specific form factors. It depends on what they're servicing. If they're servicing it as something pretty big, maybe you want a pretty big arm. Do you need legs in space or not? Or you just need something to attach. So I've seen a lot of different designs where they look at a form which is bimanual, but with a single leg. Mm-hmm. There's no need for like the two legs. And that is just there to be able to attach itself to something and maybe move around and get to the position that you want, and then it jets off somewhere else, or rockets off, like I should say.
So this be attached to like a probe of some sort? I mean, with
that's what I'm wondering.
Starship on the horizon, wouldn't you just be able to have like a service starship going up there and then you can have whatever robots and arms coming out of it and doing whatever?
Capture a satellite that needs to be replaced.
This whole
bring it into the bay and have it.
The satellites.
Yeah, mm-hmm. Yeah. That's what it looks like to me. Is that base is on some sort of platform, which is probably a bigger satellite that then moves around and gets itself in the position of whatever it needs to be done. And you probably need both arms. One to grab the other satellite to make sure it stays where it's supposed to, and the other to go ahead and grab whatever the equipment is that you're replacing.
It grabs the humanoid bot and puts it on top of the satellite.
We already have a precedence for that because the astronauts used to ride on the Canadian arm. So you had this huge arm, and the whole idea of the arm was like this crane just to get the humanoid to where they need to be. And so you could see situations like that. And you see that in industry as well. There are big industrial robots that carry smaller industrial robots in the end. Mm-hmm. And they end up getting like a 12 off kind of arm out of it, all kind of crazy. In some cases, carrying two at the same time, moving around. So, yeah, you can come up with some really bizarre configurations if you want.
Well, all right, gentlemen, we've covered so much. We missed out last weekend, but we made up for it, more than made up for it this Sunday. Thank you so much.
My fault, I was traveling.
Oh, that's okay. That's okay. And we'll see you next Sunday. And maybe before that as well. Yes. Thank you again, gentlemen. Pleasure as always catching up with you.
Okay. Yep.
Take care.